Hello. In this section, we're going to be working on multiplying and dividing rational expressions. We've been discussing recently how rational expressions are just kind of high school versions of fractions in middle school when you studied numbers. So to start, I'd like you to try the following questions, just recalling how fraction, multiplication, and division worked. So try the following. The top two questions lead us into what we're going to be talking about. There's a question in the homework that talks about a mixed number. Recall how you can rewrite a mixed number. So if you would try these three questions, pause the video now for maybe minute and a half, unpause it once you've had a chance to try and would like to see how we did this. So pause the video now, please. Okay, welcome back. So how do I multiply fractions? Multiplying fractions. When you multiply fractions, you multiply straight across. You'll notice these numbers become fairly big pretty quickly. So you might want to try to simplify where you can first. If you look, 9 and 15 both are divisible by 3, so I could divide them both by 3 and make 3/5. 8 and 14 are both divisible by 2, so I could divide by 2 and get 4, divide by 2 and get 7. Now there's no more common factors, and I just multiply straight across. 3 times 4 makes 12. 7 times 5 makes 35, and it's simplified. Over here, how do I divide fractions? I divide fractions by multiplying by the reciprocal. A little simple example would be dividing by a half. If you divide into halves, you have twice as many pieces because the pieces are half the size they were before. Dividing by a half is the same as multiplying by 2. So over here, I'd have 8/3 times 9/5. Again, I'm going to look to see where I can simplify. The 9 and the 3 will simplify to make 3 and 1. 8 and 5 don't have anything in common, so I can just multiply straight across. 8 times 3 is 24. 1 times 5 is 5. And we're going to leave these as what we call in the math world improper fractions. If you do have a mixed number, you're going to want to make it be an improper fraction. And how do you do that? Well, you do, this is 5 and 2/7. Each of the 5 whole pieces has 7 sevenths in it. So if I have 5 whole pieces, 7 sevenths times 5 is going to be 35 sevenths. So I multiply these two numbers. Now I have 35 sevenths plus the additional 2. So 35 plus 2 sevenths leads me at 37 sevenths is the exact same as 5 and 2/7. So just recall, if they give you a mixed number, you want to first rewrite it as an improper fraction. Now this is where the actual lesson starts. So we're going to be multiplying and dividing rational expressions. So here we go. First example, if you'd like, you could simplify before you go multiplying. It might make some of the the numbers a little easier to work with. So let's do the numbers first. So I got 3 and 9 would make 3 and 1. Here I have r squared and r. Well, what do I do with my exponents when I am dividing? I'd subtract. Actually, it might be easier if you just multiply straight across first. Let's do that. You could simplify all of the variables first, but it might be a little easier just to keep things organized. Let's just multiply straight across. So there's only a 1. The numbers were easy enough, so I have an r squared, an x, and a t to the 4th. Down below, I'm going to just rewrite it. There's a 3. There's an r to the 1st. There is an x, and then there's a t to the 3rd. Now it's more organized, less chance you're making mistakes, so it's 1/3. Now I'll simplify. So I still had 1/3 as my fraction. What do I do with my exponents when I'm dividing? I subtract. 2 minus 1 would leave me 1, and it's up top because the top had more. X divided by x is 1. Or if you subtracted your exponents, 1 minus 1 would make 0. Anything to the 0 power is 1. So these will just cancel out, make the number 1. T to the 4th over t to the 3rd. When I subtract, I get t to the 1st. So I get the following: 1RT over 3. You might see the book write this, as 1/3 RT. It means the same thing. So there's the first example. Second one, I have division. How did we do division with fractions? We multiply by the reciprocal. So if I have divide by 12 over 25n, I'm going to rewrite it as 4 over 15n cubed times 25n over 12. Maybe simplify your numbers first so they don't become so large. 4 and 12 will simplify to be 1 and 3. 25 and 15, they're both divisible by 5, so I'll make 3 and 5, and then I multiply straight across. And I'm going to get left with what? 5 is 1 times 5, and then there's an n. 3 times 3 will make 9, n cubed. Last part I do is I deal with my exponents. There's 1 on top, 3 on bottom. When I subtract, I'll notice it's an n to the negative 2, which means the repeated division. There's 2 n's left on bottom, or you can just look and see, hey, the bottom has twice as many n's, so it's going to end up being 5 over n squared. It'd be the exact same thing as if you did 5/9 n to the negative 2, and then notice negative exponents, repeated division, you get to the same answer. So one way or another, you have to be able to get to 5 over 9 n squared. Here's another one. It actually is identical in theory to the one that we did before. The book calls this a complex fraction. It's when you have a fraction dividing another fraction, but don't give it more credit than it's due. It's actually no more difficult than this question that we did just here a second ago. If I have a complex fraction, I'm just going to rewrite it as the following. So realize it's the exact same thing as if I wrote this as 8t squared over x divided by 4t over x cubed. So take a second, realize that this right here, fraction bar, is the same as that division symbol. They mean the same thing. Now, how do I do divide? I multiply by the reciprocal. So this is just 8t squared over x times x cubed over 4t. Simplify the numbers maybe when you can. 4 and 8 will make 2 and 1. Now I'm going to just multiply straight across. That'll leave me at what? 2t squared x cubed. Down below, there's a 1 and a t and an x, just organizing my like variables on top of one another. 2 divided by 1 makes 2. T squared over t to the first is just t to the first. X cubed over x to the first, subtract, I get x squared. And there's my final answer. So don't be intimidated by a complex fraction. Is really no different than writing it as we had the one prior. Last part before I ask you to try one, I believe, is a little bit about something called dimensional analysis. It's used when we are converting between units, and it actually is a similar process to how we're multiplying and dividing rational expressions. So an example, let's say a scarf bought in Italy cost 18 euros. The exchange rate at the time is $1 is equivalent to 73 or 0.73 euros. How much did the scarf cost in US dollars? So let's start with what we knew. We knew that the scarf cost 18 euros. So 18, and I'm not 100% certain what the euro symbol is. I think it's that. If not, go with me on it. So 18 euros. Now I need to convert it to be how many dollars? So how we're going to do this is we're actually going to use a clever mathematical idea, and that idea is we can always multiply by the number 1, and it won't change the value of the number. It might change how it's represented, but it doesn't change the value. Essentially, it's a valid mathematical move. The value of 1 that I'm going to multiply by is this conversion rate. I'm going to use the conversion rate as my fancy number 1. So I'm going to multiply by the conversion rate. I need to get rid of euros, and euros currently are on top, so I need to put the euro conversion rate down below here, 0.73 euros. 0.73 euros is equivalent to $1. So I hope you realize this statement right here is really just the number 1 because the top and bottom are equal to one another. Whenever you divide something by something that's equivalent to, it's really just a fancy number 1. That's why this is a valid mathematical move. Now, how do I multiply fractions? I just multiply straight across. Tops times tops, bottoms times bottoms. Realize, though, in doing so, the euro unit on top is going to cancel the euro unit on bottom, and the only unit that will survive is the dollar unit. So I end up with 18 times 1 is 18 dollars divided by 0.73. 18 divided by 0.73 turns out to be, rounded to the nearest cent, is going to be $24.66. That's how you can use conversion rates to convert between one unit and the other using dimensional analysis, just multiplying by an irrational expression. Let's do it one more time. Let's say if at the same time 1 Canadian dollar is equivalent to 95 US cents, how much did the scarf cost in Canadian dollars? So again, I'm going to start with what I know. I know it's $24.66 American. And now I need to multiply by the Canadian dollar exchange rate for the US dollar. So I need to multiply by the exchange rate. Again, this is US dollars, so I need to put the US dollar down below, and that's 0.95 US dollars. Up top is 1 Canadian. So I'm going to use a C here to stand for Canadian, so I don't have common dollars and dollar units going on. Now I'll notice US dollars cancels US dollars. What do I get up top? I get 24.66 Canadian divided by 0.95. And if I take 24.66 divided by 0.95, it'll give me the value in Canadian, which is 25.96 Canadian. That's not bad. That's just one step. It turns out you can do this process for items that even involve more conversion steps than just one. So this last part before I have you try, I don't believe is actually in the note packet that I currently have for you. If it is, then awesome. But if not, just follow along with this idea. I'm giving you a little preview of the dimensional analysis that you use in chemistry and physics. So this is a little preview for those that'll take this class in the future, or maybe have seen it even before. So maybe I want to convert 75 miles per hour into feet per minute. Here I've got 2 units going on. I can actually use dimensional analysis, rational expressions, in order to convert between one and the other. So I'm going to start with what I know. I know 75 miles per 1 hour. And I need to eventually get to feet per minute. So I'm going to have to multiply by a bunch of fancy number ones. So here's my first one. Doesn't matter if I want to get out of miles or hours first. Let's say I'm going to go after miles. So I want to get into feet, and I need to know what the conversion is between miles and feet. If you need to, you can look it up. It turns out that 1 mile, and the reason I'm going to put miles down below here is because miles down below, I have to cancel the miles up top, has 5,280 feet. I wouldn't want to write this the other way because I need miles and miles to cancel. So this mile will cancel with that mile. Now I would be in, if I type this in a calculator right now, it's 75 times 5,280. I would have how many feet in an hour. But I don't want to know feet in an hour. I want to know feet in a minute. So how am I going to get to minutes? Well, in 1 hour, there are 60 minutes. So I'm going to put hours on top here because I need the hours down below to cancel with the hours up top here. And I need to put 60 minutes down below. This is just a fancy number 1 because 1 hour is equal to 60 minutes. Notice again, hours will cancel with hours. And I'll have feet per minute, which is what I want. Now I just need to type, oops. Now I just need to type in the calculator. I don't know why it's doing that. There we go. Now I just need to type in the calculator 75 times 5,280. So I just multiply the tops by the tops, bottoms times the bottoms. I end up getting 75 times 5,280 is 39600. That is feet divided by 60 minutes. So I needed to take that number divided by 60, and I'll end up getting that 75 miles per hour turns out to be 6,600 feet per minute. So there you go. It actually turns out to be a very, very useful and applicable tool. I'm going to ask you to try. So pause the video now, and I'd like you to try the following 2 questions. Can you do a division of rational expressions question? Recall how we divide with fractions. And then can you do a dimensional analysis question that I have set up for you? Find the answer and then include the units in your final answer so we know what the units are actually telling. So pause the video now, try these 2 questions, unpause it once you have completed practicing. So maybe minute, minute and a half. Okay, welcome back. Going to go quickly through this. How do I divide with fractions? I multiply by the reciprocal. So I take the original statement and multiply by the reciprocal the second. Simplify the numbers first might be helpful. 7 and 21 will make 3 and 1. 6 and 4, if they're both divisible by 2, will make 2 and 3. Now I'm going to multiply just straight across and then line up my variables. 3 times 3 make 9. I get a c squared and an x cubed. Down below, 2 times 1 would be 2. C squared x, simplify. 9 over 2 won't simplify, so it's 9 over 2. C squared over c squared. That's just c to the 0, which is 1, so those are going to straight cancel out, make the number 1. X cubed over x to the first will make x squared. So I get 9x squared over 2. You might see this written as 9 halves or 4.5 x squared. They mean the same thing. Second one. Cancel out all of your like units. Gallons of gas will cancel with gallons of gas. Phillips will cancel with Phillips. Months will cancel with months. And what do I have left? I have dollars per day. This is an estimate of how many dollars per day someone would spend over a month filling up their gas tank. And that turns out to be about $4.28 per day if I multiply 2.85 times 15 times 3 and divide by 30 down below. So that's the first half. Second half deals with where we might have to, before simplifying, we might have to factor first. So consider the following example. I have 2x plus 6 over x squared divided by x plus 3. Dividing by x plus 3, it doesn't look like it's really a fraction, but it is. I can always write it over 1. So this is really 2x plus 6 over x squared. Instead of dividing, I can multiply by the reciprocal. So the reciprocal of x plus 3 over 1 is 1 over x plus 3. Let's factor it first, so I might be able to find any common factors. If I look, x squared can't be factored. X plus 3 is already x plus 3. That already is a factored expression. 1 is the number 1. The 2x plus 6 can be factored. I can do greatest common factor factoring. I can divide out 2 is the biggest number that goes into 2 and 6. I can't divide any x's out, so I get 2x plus 3 over x squared times 1 over x plus 3. Now, how do I multiply fractions? I multiply straight across. I'm left with 2x plus 3. The 2 and the 1 multiply, so the 2 is just absorbing the 1. Down below, I get x squared over x plus 3. And then note, these are like terms on opposite sides of the same fraction, so these will factor out, or cancel out, make number 1. I'm left with just the statement 2 over x squared. So the benefit of factoring is I'll be able to see when I can cancel things out because they have a common factor on top and bottom. I think this is the last one we'll try. We're really going to go to the extreme with this. This is as challenging as it can get, but really it's just applying a lot of the things we've done in the past. It's factoring with dividing and fractions. So it's a complex fraction. So really the first step is just realize this is kind of similar to the one we did before. This fraction bar in the middle could just be used to rewrite with a division symbol. So I'm going to just rewrite the problem. There was really no math that went on in that first step, just realizing I can rewrite this with the division symbol instead of having a fraction. Well, how do we do division? Instead of doing division of fractions, I can always multiply by the reciprocal. So I multiply by the reciprocal of that second statement. And now what I'm going to do is, before I go simplifying, look and see what can be factored. Well, this top one is already a factored expression, n minus 1. Over here, n squared plus 7n minus 18. What two numbers multiply to be 8? Multiply to be 18 and add up negative 18 and add up to be positive 7. Oh, that's going to be a positive 9 and a negative 2. So x plus 9, x minus 2. Down below, same type of question. Multiplies to be a positive 1, adds up to be a negative 2. It's got to be x minus 1 times x minus 1. Over here, this is n squared, really plus 0n minus 81. This is a difference of squares. The two numbers that multiply to be negative 81 and add up to be 0 have to be the same number, but opposite in sign. So plus 9 and minus 9. And then I have, oh, was I writing x's? All of these should be n's. Process is still the same no matter what you call the variable, but should probably be consistent. X's and n's aren't going to talk to one another. So n minus 1. Now everything is factored. Multiply. You'll realize what can cancel out, but I'm just going to be very organized with it so I don't cancel inappropriately. I have n plus 9, n minus 2, n minus 1. Over here, n minus 1, n minus 1, n plus 9, n minus 9. Now, I just find anything that's a common factor on top and bottom that'll simplify. N plus 9 over n plus 9, those will cancel each other out. N minus 1 over n minus 1, those will cancel each other out. The only thing left behind is an n minus 2 over n minus 1 times n minus 9. And you'd be done. I can't remember, you might see the book write the final expression as n minus 2, and they might actually multiply this bottom part out as n squared minus 10n plus 9. If they do, that's all they did. It's the exact same statement. So that's a challenge you just can get. Really, it's just organization. It's just dividing a fractions, multiply by the reciprocal, factor everything that you can, multiply, and then cancel any common factors. I'm going to ask you to try one. So pause the video now for maybe a minute and a half, 2 minutes. give it a try, see how you did once you've tried it. So pause video now, please. Okay, welcome back. Here's the answer you should have got. X times x plus 2 over 7. Just real briefly, how do you get there? You got to factor the top part here. This will end up being x plus 1 times x plus 12 over 7. How do I divide? I multiply by the reciprocal. I will realize once I multiply straight across that this x plus 1 and that x plus 1 will cancel each other out, make the number 1, and I'm left with the following statement. So that is it for today. Thank you very much, and have a good day.